Hi there! Welcome to our virtual tour and short film on the analysis of HVAC system in the GSK Carbon Neutral Laboratory for Sustainable Chemistry. Before we go into details, let us introduce you briefly about this building. The GSK Carbon Neutral Laboratory for Sustainable Chemistry is a chemistry laboratory located on the Jubilee campus of the University of Nottingham and is part of the university's School of Chemistry. With a total floor area of 4,500 square meters, the two-story building was designed by FDG and completed in the year of 2016. This laboratory is one of the first buildings in the world to obtain both the BREEAM Outstanding and LEED Platinum with a total score and rating of 94.1%. The climate of Nottingham features a temperate maritime climate with relatively mild summers, cool winters, and abundant rainfall throughout the year. The length of the day with sunlight in Nottingham varies extremely over the course of the year. The convenient building includes state-of-the-art teaching and research laboratories, writing up areas, school outreach space, academic offices, seminar rooms, and communal winter garden designed to capture low-level heat in the spring. The building is angled to control the amount of UV light received into the interior and provide specific direction of shade. Its distinctive structure and shape is partially informed by the orientation, with its north facing expressed as a sloping green roof with a shaded entrance cast from the adjacent protruding structure, and its south-facing pitch clad in photovoltaic cells where the south side receives the longest hours of sunlight. The strategies for spatial planning is to minimize solar heat gain while capitalize on natural daylight in order to maintain thermal and visual comfort passively, which reduces the need for energy consumption. The building has been recognized by the Structural Timber Awards in 2016 for the innovative uses of timber. The natural materials are chosen for their low embodied energy. Overhangs and deeply set double-glazed windows are further design cues chosen to control the internal environment, adding to the distinctive aesthetic yet remaining true to the philosophy of the project. Constructed with a glue lump frame, CLT panels form the floors, roof deck, exterior walls, and a number of internal divisions. Exposed timber finishes internally ensure limited linings and the resulting carbon benefit. The outstanding properties of the wood as a store of heat and moisture guarantee a balanced interior climate. Besides allowing maximum daylighting into the interior, the double-glazed windows reflect heat to minimize solar heat gain, which in turn also has a positive impact on the people's health. The building also makes use of air and ground source heating, while a main lake acts as a heat sink which contributes to the geothermal energy. The undulating roof form is a direct expression of sustainable design drivers that generates power, emits daylight, and embraces biodiversity. The extensive green roof, including drought-resistant crops and native species, embraces the biodiversity by incorporating a green landscape that covers one side of the building and assisting rainwater attenuation that do not require an irrigation system to be installed. The structure is designed to offer maximum ability to change or redesign lab spaces in a matter of hours, and the absence of ceilings in some labs not only provides light, airy space, but also means all pipework is readily accessed, making maintenance easy.
The air ventilation system that is used in the building is a hybrid design. It has won a host of sustainability awards, including the 2017 Heating and Ventilation News Renewable Project of the Year title. The innovative strategy in the building is the ventilation tower that's standing at a 45-degree angle and cantilever from the base, rising almost 10 meters above the ridge. These distinctive horns are used to release high fuel gas at high discharge rate to reduce the discharge velocity of fume cupboards. The building shape creates wind pressure at the ridge, allowing it to direct incoming air into the laboratory and via heat exchangers to provide heat recovery. The roof-mounted ventilation coils also help to achieve air ventilation. This method saves up a lot of energy consumption, increasing with more fume cupboards installed. Laboratory design and equipment supplier has supplied a variable air volume fume cupboard solution for the laboratory. When the blower connects to HVAC system that have activated, air started to flow into the fume then blow out to a duct through a buffer. It also has an automatic fast closer when user walk away, they set back on volume. This automatic SAS controller can save energy by 40% and limit risk of explosion. 52TEL AFA1000 controllers is provided to control the fume cupboards. It can control a damper by using a door sensor, an air volume sensor, and air discharge of volume by controlling a blower. One blower drives the air for 10 fume cupboards rather than having a fan for each. With it, they can save a lot of energy. After that, the air will be transferred through duct to ventilation tower. First is the cooling system. It has only been installed where absolutely required, like room with heat generating equipment. Decentralized cooling system is used to supply the required temperature and flow rate without energy losses in distribution. The chiller that is used in the labs is R1234ZE chiller. According to the report, R1234ZE is better choice and saves 9.4% of the total energy destruction than R1. Next is the heating system. The building used a biofuel combined heat and power unit to warm up the spaces with a gas fire boiler as backup. Combined heat and power plants use the waste heat from electricity production for heating purposes. For a conventional power plant, it only uses 35% energy and 65% energy will be wasted. However, combined heat and power plants optimize energy use. The CHP unit at the building can generate 200 kW of electrical power and 193 kW of heat. The heat that generated from the CHP will be transferred to spaces by underground floor. Then is the monitoring system. Weather station is installed on the roof to measure atmospheric conditions so building can quickly respond to adjust the use of energy, especially for HVAC. To monitor the use of energy in the building, submeters are installed on all major energy consumption systems. This includes space heating, hot water, and cooling. A display screen in the central foyer shows real-time energy consumption data. Monthly energy reports are produced and shared to both internal building users and GSK. Besides, they are also monitoring the working hours in the building. They will identify the every working hour so they can allow the simple setback of system to achieve significant energy saving. To operate this building, especially for active system, energy is needed, and the energy required is met by renewable and low carbon sources such as the PV array covering 45% of the roof area and sustainable biofuel CHP. Excess energy created by the building will offset embodied carbon of construction over a 25-year payback.
Principal aim of this building is to develop, is to think about sustainable chemistry. What better place to do it than the world's most sustainable chemistry laboratories? This space really is like the heartbeat of our society now. It's become the central meeting place for all of our scientists, and actually loved by the rest of the university community.
According to the post-occupancy evaluation, this building has received a lot of positive feedback and review from the public, where the building has successfully delivered desired services and facilitated the development of low energy strategies for its operation, with ongoing monitoring of its performance providing valuable lessons to improve the way it and other future buildings operate. Laboratories are energy-hungry places with demands for ventilation, power, and water, all of which have environmental and cost implications. But with using thoughtful design and working with user, GSK neutral carbon laboratory have become more efficient, significantly reducing their energy, water use, and environmental impact to enable this low carbon ambition.
Thank you for watching. Hope to see you soon.